Welcome back. Problem 9.84. So statement is for the beam shown determine the reaction at point B. So you can see this is the beam AB that is fixed support at point A as well as point B. And at point C we have a moment that is given by M naught. The total length of the beam is L. Now you can see that both ends are fixed. So if you remove this support, so there will be a reaction force RA and there will be a moment which is MA. Same is the case. You will have a reaction force RB and there will be a moment of MB. Clear? So you from here there are four unknowns. So this beam is indeterminate beam and that is second degree indeterminate. So what we will do is that we have been asked to find the reaction force at reaction at point B. So reaction at point B will be this one, this is RB and there will be a moment as well which is MB. So we are interested in to find RB and MB. So what we will do is that since beam is second degree indeterminate, so what we will do that we will choose RB and MB as redundant reaction and we will solve then redundant reaction and we will solve them separately and apply the method of superposition. So this beam, if I draw it individually, so this is the fixed support, this is the beam, clear, and this is the fixed support, this is your point A, and if I represent RB is like this, so RB is like this, so it will be your case number 1. The total length of this beam is L. Clear? I will write it over here L. This is your case number 1. For case number 2, what if I represent the same beam and now I will choose moment RB over here, only MB and same length. So this will be your loading 2, clear. And the third scenario is that if you represent same beam with a reaction support, the length is L, and at point C we have a moment that is M naught only. From this point till this point, this is L by 2, and same is the case, this is L by 2. The total length is L. Now you can see if I add case 1 plus case 2 plus case 3. So it will, if I add all this, so the effect will be represented over here. In first case, I have taken only RB. In second case, I have taken this MB. And in third case, I have taken this with a moment. And their sum, case 1 plus case 2 plus case 3 will define this condition. Now we will write the deflection and slope equation for each case. So for loading 1 or case 1, you can see case 1 we have a point load at one end of the beam and the other end is the beam is fixed, that is cantilever beam. So we will go toward appendix D and we will check this case and write the equation of slope and deflection. So here you can see the same case. This is the first case, loading is shown over downward, so your deflection will be this one and your slope will be this one. So note down, we will write them over there. Here we have in question we have this RB, so P will be replaced by RB and rest all the things will be same. So YB due to case 1 or loading 1 will be equal to minus RB into L cube over 3EI, and theta B1 due to loading 1 will be equal to minus RB into L square over 2EI. Now what will be theta B? So due to this RB, it will bend like, it will deflect like this. So this is your YB1, deflection due to loading 1, and this will be your slope theta B due to loading 1. So both are written over here. Now we will move toward case B. So loading 2. So loading 2, you can see that this is a cantilever beam and there is a movement at one end. So we will check it in appendix. Now from in this appendix, you can see this is the loading. This is the condition. The beam is fixed support at one end and there is a movement given over here. So your deflection will be this one and your slope will be this one. So note down and we will write it over here. So YB due to loading 2 will be equal to MBL square, MB into L square over 2EI, and slope will be theta B2 will be equal to MB into L over EI. Why both are positive? So I will explain. Due to this movement, it will be move like this. It will be move like this. So this will be your YB due to loading 2 and this will be your slope theta B due to loading 2. So both are positive. Now in third scenario, you can see that you can see that this movement is at a length of L by 2. So it will be same like this, but L is replaced by L by 2. So I will directly write down this third one, loading 3. So in loading 3, your YB, sorry, not YB. Now you can see this will be YC because this is point C. So YC, because this portion will remain straight. So this distance will be equal to YC due to loading 3. And this will be slope theta C due to loading 3. So YC will be equal to M0 into L by 2 whole square divided by 2EI, and that will be equal to M0 L square over 8EI. That is loading due to loading 3. Similarly, theta C due to loading 3 will be equal to M0 into this L will be replaced by L by 2. So L by 2EI. Now what about this YB? This is your point B. So YB due to loading 3. So YB due to loading 3 is equal to YC due to loading 3 plus L by 2. This is L by 2. L by 2 into theta C due to loading 3. I will explain it now. You can see this YB is equal to this distance, which is equal to YC3 and remaining this distance. And this distance will be equal to, this is L by 2, this portion is L by 2, clear, and this theta will remain same, theta c due to loading 3. So by using S is equal to R theta, so this S will be equal to theta into L by 2, this L by 2, clear. So I have written it over here. You can just put the value. So YB due to loading 3 will be equal to M naught. Okay, so this will be, okay, again I have a mistake. This will be like, this will go like this. So you can just reciprocate it over above. Rest all the concept is same, clear, and you will get this YB3 is equal to M naught L square over 8 EI plus M naught into L over 2 EI. Now we will apply superposition and constraint. So superposition and constraints. We know that due to superposition, YB1 due to loading 1 plus YB due to loading 2 plus YB due to loading 3 is equal to total deflection at point B, which is equal to 0, because this B is fixed support. So YB will be equal to 0 and theta B will be also equal to 0. So you can just put the value, YB1 is minus RB into L cube over 3 EI, that is mentioned over here. Similarly, YB is this one, which is plus MB into L square over 2 EI plus YB3, which is M naught L square over M naught L square over 8 EI plus M naught L over 2 EI. Okay. So again, this is the value of theta C. I haven't multiplied it with L by 2, you can see. So if you solve this, YB3 will be, I will also write YB3 is 3 by 8 M naught L square over EI. So instead of these two value, you can also write this. Again, this will be L square over 4, because you have to multiply it with L by 2. So it will be L over 4. Or you just replace this value with this single term. So again, this will be equal to minus RB into L cube over 3 EI plus MB into L square over 2 EI plus 3 over 8 M naught L square over EI. This is your equation number 1. And this equation contains RB and MB, so it cannot be solved. So you can convert equation 1 in term of RB. You can move this term and this term to the right side and equate it equal to RB. Now we will apply another constraint, that is theta B is equal to theta B due to loading 1 plus theta B due to loading 2 plus theta B due to loading 3, and we will add them and it will be equal to 0, because the constraint at point B, it is fixed support, so theta B should be equal to 0. So you have all the value theta B1, theta B2 and theta B3. Theta B3 we did not find. Theta B3 will be the same as theta BC. So again, theta B1 is RB into L square over 2 EI, and that is minus, I will show you, this is the value RB2 is MBL over plus MB into L over EI, and theta B3 is equal to theta BC because the slope is same. So it will be 1 over 2 M naught into L over EI. Their sum must be equal to 0. And this is your equation number 2. Now equation number 2 also contain RB and NB. Either you can solve them simultaneously or you convert equation number 1 in term of RB and put it in equation 2. So I will directly write, you should solve it by yourself. So solving equation 1 and 2 simultaneously, you will get RA will be RB is equal to 3 over 2 M naught over L. So our value is positive. It means that our assumed direction is correct and RB is downward. And movement about point B, when you get RB, you can put it in either equation 1 or 2. So you will get MB is equal to 1 over 4 M naught. This value is also positive. So it means that our assumed direction, which was counterclockwise, is correct. So these are the answer of our this question number 9.84. These are the reactions at point B. I hope you have enjoyed this video. Again, if you are new to my channel, then subscribe it and keep watching the videos. And if you have any question, you can ask me in comment section. Thank you for watching.